Okay, this is exhaust chamber calculator version 29, sheet 1. If you look at the bottom left, you'll see the tabs for each sheet. There's 4 sheets. And right here is the steps for pipe design. You start here on sheet 1, then you go to sheet 4, then you come back to sheet 1. So let's just go over it step by step to make sure you understand how it's done. Step 1 is input the exhaust and transfer port durations, which will be right here, and the start of power band RPM, which will be right here, and the bore and stroke, which is bore right here and stroke right here. So if it's on a known engine and you're going to be making a pipe for it and you like the pipe power band as it is, you would write it, and if you notice right before you get on the pipe you have a power dip, okay? And then when it starts getting on the pipe, you can actually hear the pipe start to resonate, and you can start to feel the beginning of the power surge, okay? So that's the start of the pipe power band, okay? If you don't know the exhaust gas temperature, well, we'll get over that later. Okay, so step 2 is complete sheet 4. Yeah, okay. So you click on the tab, you go and you enter in all the stuff here. On all these sheets, the light blue cells are the ones where you enter the data, and you leave the others alone. And this is the calculate button. So that determines the time it takes for the exhaust pulse to go to 0, pressure-wise. In this case, it's 0.69 milliseconds. And that's needed right here on sheet 1 to do some of these calculations. Okay, step 3 is enter the exhaust gas temperature. It should be these 3 cells right here. If you don't know what it is, and the bike is running now, if the temperature you have set here at 600 degrees at 10,000 RPMs at 150 millimeters from the piston is too hot, it will tell on sheet 3 that the beginning of the power band is earlier than you think it is. Okay? And if it's too cold, it'll make it later than you think it is. So you can determine what the exhaust gas temperature is by synchronizing this graph with reality. Or you can measure the exhaust gas temperature. Yes and no for if you have a reed valve. Yes or no if you have ignition timing curve. Almost all modern bikes have ignition timing curve, but some people with old bikes, like old motocross bikes, have a set timing. And if it's set timing, put in here, and then you've got to enter in these 2 data sets, which I'm not going to go into the specifics right now. So engine data at F29, that's the bore and stroke, which I need to erase that right there because I cover it right here. Okay. Enter pipe diameters at H31 to M29. So they're talking about this area right here. So we've got the beginning header inner diameter, end header, inner diameter. If you're analyzing a pipe and you know where the straight part of the header ends and the flared part of the header begins, then you can measure the flared header until the diffuser and put that distance here. And then as with those two diameters, it'll show you what that angle is from the center line. It gives a recommended belly inner diameter, which you can go a little bit more than that, but it's not, you don't get a lot more out of it if you do. Right here you enter the belly diameter. According to the stinger length, it'll recommend a stinger diameter, and you'll put right here the stinger diameter that you're going to use. I recommend it be this diameter or a little bit more. Like in this case, it's 9.9, so right here I should put 10. But it depends upon what's available to somewhere along here. Yeah, this right here lists the typical inner diameters that are available at Metals Depot if you're making your own pipe. So, okay, pipe diameters. Step 5. Vary the lengths of the belly header and diffuser according to A21 to C28, which is these recommendations right here. It tells you add or subtract. Like if I make this too short, it'll tell me to add 101 millimeters. Of course, the lengths of the diffuser, belly, and baffle should all be divisible evenly by 10. So instead of adding 101, I'd add 100 to make that 340. But let's just use the calculate button here. Sometimes you have, like I said, a straight section and then a flared section. Even if this straight section is just from the piston to the beginning of the pipe where it starts to flare out. So click right here for flared header. It will recalculate and set right here the lengths. You have to choose the belly, the baffle length. Baffle length for a racing bike is usually anywhere from 100 to 180. Let me just tell you right straight up, don't talk angles on baffles. It's not about the angle, it's about the length. Because you can get the same effect from a big bore pipe as well as a small bore pipe. And to have the same effect, you've got to have the same length, even though the angles are different. So the program figures out the angle. Don't worry about that. But when you're talking about how to choose a baffle, you don't go by angles, you go by lengths. For a street or trail bike, the lengths are about 180 on up, as much as 300. This right here is my pipe design guide. I forgot to mention that, which suggests a flared header for a racing pipe, a straight diffuser for a racing pipe, a 3-cone diffuser for a street or trail bike, and this is a street or trail pipe, and this is a racing pipe. So like I said, if it's got a flared header, you just click here, flared header, calculate. If it doesn't, set the flared to 0 and click calculate straight header. So this calculate button will set all these lengths for you, and they are pretty darn close to being a really, really good pipe. On sheet 3, you click the autograph button here, and it'll graph that power band and power. And then if you don't like it, you want it to be longer, you want it to be shorter. Like this has an early surge, you might want to design it for a later surge. You know, you can make little changes from there. But to start off with, I really suggest you go with what the computer program calculates for you. Don't forget to enter the number of cones you're going to use if you're going to be going with this design or this design. And this right here is the pipe metal wall thickness at the header and for the rest of the pipe. So yeah, that's pretty much it for sheet 1. What's the next step here? Next step is go to sheet 2 to design the diffuser and the baffle cones. Yeah, so that'll be on the next video.